Flattening the curve is reference to a graph made by the CDC used to help in the situation of a pandemic. There are two variables, x being the time since the first case and y being the amount of cases. But there's a benchmark line showing the amount of ICUs or ventilators or just general amount of space that the country has. The higher the curve, the more cases in a short amount of time, which means less space. But to flatten the curve, you need to spread out the amount of cases with more time so that there's enough available slots in hospitals so that people can be cared for. Some people don't follow the guidelines set to help people stay healthy. But let's say no one did. Life kept on how it was and everyone was just out and about. The worst case scenario would have the highest curve. Everyone would be getting cases and sick, and a lot more people would be dying than what there are now. But a moderate scenario, let's say people did two of the guidelines at all times, no matter what, like staying home and washing hands. You would get a manageable scenario like what we have now. But if everything were to stop and all guidelines were followed at all times, you would have the best case scenario, and the curve would be small, and there would be lots of space in hospitals for people that got the virus. The curve that the CDC uses is a quadratic equation. That's just one of the many examples that you can use for a real-life scenario. You can use quadratic equations for just about anything. Most commonly for balls that are being thrown or kicked into the air. Other examples could include finding the length of something, the curve or an arch of a bridge, and the maximum profit of an item. The real-life examples would be something like this. Let's say you have a soccer ball, and you're super bored and you want to know how high you can kick it. So you do a quadratic equation to figure it out. You get all that you need. The a value of -16 representing the gravity of the equation. You can kick a ball, and at an easy math standpoint, of 32 feet per second. And since you're 0 feet off the ground, your c value is going to be 0. After that, your equation just turns out to be ht equals -16t to the second power plus 32 plus 0. And that's it.